Okay, let's review limits from last year. Hopefully you had a chance to look at limits, and you're going to have a better chance to look at them a little bit more in depth this year. And the question is, which one of these has a limit as x approaches 1 that does not exist? In other words, there is no limit. So the easiest way to do that is to grab your pencil and trace the graph as x gets closer and closer to 1 from both sides of the graph. And what you're looking at is seeing if those two arrows match up, which in this case they do. So in this case, choice A, the limit does exist as x approaches 1. So it's not what we're looking for. So let's look at B. Again, trace it from as x approaches 1 from both sides. And you can see that even though there's a hole there, the graph still matches up on both sides of the graph. So the limit does exist. Let's go for D for a second here. And again, it's another one that has a hole in it. But if you notice here, when I trace it from both sides of the graph, the limit exists because, again, both sides are approaching the same value. Okay, so let's look at C now. Well, this one, notice here, when I approach it from the left side, as x approaches 1, and from the right side, you can see that they are not going to the same value. So this is the graph that the limit does not exist. So my correct answer here is C. Okay, so again, same graphs actually, but now we're going to look and say which of the following has a limit of x as x approaches 1 of f of x equal to 1. And again, if you look at this and trace it from both sides as x approaches 1, we're looking at the y value that we're getting closer and closer to. So in this case, hey, x does approach 1 from both sides of the graph. So choice A is one of our choices. Okay, now we look at B. You notice, again, we trace from both sides, but in this case, it gets closer and closer to the y value of 2. So this is not what we're looking for. We had looked at from the previous example that C is a graph in which the limit does not exist, so we know that can't be the answer. But if we look at D now, again, tracing from both sides, we can see that the graph as x approaches 1 actually approaches the y value 1. And the y value is 1. So again, in this case, there's actually two graphs that have the same answer. Okay, so let's take a look at C, for example, because this is the one, remember, the limit does not exist. We're going to introduce some notation here to show that what are the criteria for a limit to not exist. So if you notice, remember here, when we traced the left side of the graph, which is what we call the left-hand limit, we're going to denote that with a little negative symbol there of f of x. We saw that it was a little bit different than the right-hand limit, which we denote with a little positive symbol. These are both what we call one-side limits. Those limits, if you notice, exist. Remember, this was equal to 1, and the right-hand limit was equal to 0. And since these are not equal to one another, we then said that the limit as x approached 1, notice no positive negative symbol, so we're looking at the whole limit, we actually say equals d and e that does not exist. Okay, so let's learn how to determine limits algebraically. The easiest way to do limits is to do simple substitution. And you should always do that first, actually. Replace the x with the value that you're trying to find the limit for. So 4 squared minus 5 times 4 minus 4 equals negative 8. And so that is what the limit here. Real simple to substitute. Let's take a look at the next problem now. However, here, when we substitute here x approached 4 for every value of x, you'll notice here that we'll actually get 0 divided by 0, which is what is called an indeterminate form. And that form, it means that there is an answer. We can't determine it this way. So 0 divided by 0 means there's still an answer. We just got to look for a different way to find that answer. So to find that answer, the easiest thing to do is usually by factoring. Okay, remember your generic rectangles from Algebra 1. You do this by factoring. And so if you notice, the top factors to x minus 4 times x plus 9 over, we still have x minus 4 in the denominator. You notice now the x minus 4's cancel. So we can find the limit by replacing our x equals 4 into our function. So 4 plus 9 equals 13. Okay, well, there are other kinds of problems. Here's another problem that when you try to do substitution here, you'll notice you'll get 0 divided by 0. But this one, if you notice, is not a squared equation, so we usually do this one by doing synthetic division. So if you remember for synthetic division, you put -2, the value that creates 0, here out front, and you put the coefficients underneath. So 1, -3, -8, and 4. Synthetic division requires you to drop the first number always, multiply, and then add. And you keep doing that all the way across. Multiply, add, and here you get 0 as a remainder, which in calculus will always be true. So remember, we need to write this as an equation. This is as the coefficients. So if you remember, our equation started at x cubed, so our exponent always drops by 1. So this is the equation, x squared minus 5x plus 2. And to finish up this problem, we can then substitute x equals -2 in this equation and get 16, which would be our answer then. The last problem I want to show you looks like a fraction again. So you think, oh, factoring, synthetic division is going to work. But notice here that when you replace x with 2, you actually don't get 0 divided by 0. You actually get an answer here. So again, this can be done substitution. So always do substitution first. Then, if that doesn't work, look for other alternatives. But don't forget to do the substitution here. So this one would be 4 plus 4, 9 over 3, which gives you an answer of 3.